For question 4, we have the question: when a particle falls through the air, its initial acceleration a is same as gravity. It will diminish until it is 0, and therefore it falls at a constant velocity vf. If this variation of acceleration can be expressed as acceleration equals to g multiplied by vf square minus v square divided by vf square. Determine the time needed for the velocity to become v less than vf. Initially, the particle falls from rest. So how do we solve this question? Where we are given this equation where there is no time given and we're supposed to find the answer with respect to time. Determine the time needed. Okay? So now, first we must understand that acceleration is the time derivative of velocity. So with this, I can relate acceleration with time. Okay? Now, this equation can be brought down over here because this is same as acceleration, and then we recognize that this is a first order separable differential equation. Then we bring all of this to the left side and dt up to the right side, because we will be integrating this with respect to velocity and integrating dt by itself, which is, it will give up t lah. So over here, we know that from the integration formula there is such integral formula. So this is the hint for this question. Now this seems like quite hard to integrate and very difficult to integrate, but we look at the clue that's given to us. Constant velocity vf, meaning to say I could take vf as a constant and I can take it out of the integral. Just like gravity acceleration, I can take it out because it is constant, it will never change. And we know that the particle initially falls from rest, so the velocity at the initial part will be 0 and the velocity at the final part will be v. And dt by itself, the time starts from 0 and we don't know what time is it, so we put t at the end. So when we do this integral, this, you see this form is same as the integration formula form over here. So just follow the formula and then you can get the answer over here. So this question is quite easy to understand because this question is just simply a form of terminal velocity, because initially it will fall at a very high acceleration and it will slowly diminish until it falls at a constant velocity. So this is like a terminal velocity question. So yeah, hope you understand.